Okay, so here we are in Desmos. This is desmos.com. You go to the graphing calculator. And we're going to enter our function. I'm going to type it in, but you also have a keyboard option down here. If you're ever unsure what to type in or what the shortcuts are, you've got all of the options down here. So like here's a square. You've got functions over here. So you could click on sine, cosine, and tangent, or the inverse functions if you need them. So you have this whole option down here. I'm just going to go ahead, even for the most part, it's just easy just to type it in. So I'm going to put in y equals 3 plus 2 sine, and I'm going to go ahead and always put parentheses. Oh, hold on. Mistyped that. I'm going to go ahead and always put parentheses around the sine, cosine, tangent part. Sometimes it reads it okay, sometimes it doesn't. It's safer just to go ahead and be very clear and put those parentheses there. So I typed this in exactly how we had it on our other page. You could also just type it in without the y, and it'll come up the same. So see that? Red, blue, same thing. Okay, so with the y, without the y, it comes up the same. Also, if you noticed, I typed in sine. So look, I've typed S, I, it's looking at those like variables. But then when I do n, it recognizes that as sine. So you can just type in sine, cosine, tangent if you don't want to go into that menu. Okay, so for the most part, pretty straightforward on typing it in. Okay, and we get our function. So this looks a little bit different from what we drew by hand, and that's just the scale of it. So what we want to do is we want to adjust the graph settings to be what you want it to look like. So there's no one setting for this. You want to make sure that you can see at least one period. So we can see this S shape right here. I want to make sure I can see at least one S shape and maybe a little bit more on either side. But this is pretty zoomed out. This is kind of busy, confusing. I don't want to see all this. So let's adjust our graph settings. I usually click off of the minor grid lines because it adds a lot of clutter. So I keep grid and axis numbers all the time. The x-axis and y-axis you can adjust here, or you can actually just click on it and slide it around. You can zoom in, zoom out if you've got like I've got a touchpad that does that, or if you're on a mobile device, you can pinch in or zoom out just like you would any website. And when you look, see how that adjusted my X's and Y's, they're not whole numbers anymore, which is fine. Like we said, we've got a lot of repetitions here. I really just want to be able to see one period clearly. So this, I don't need this much on the X's. So let's just go -1, 2, 4. Okay, so that cleans it up a lot. Now I see like one period nice and clear right here. Okay, and a little bit extra, that's okay. We don't want to zoom in too much, and we don't want to be zoomed out too much. So the X's are pretty good. The step, I'm usually going to be in some sort of increments of pi. I'm just going to type in pi, pi, and it changes to the symbol automatically, which is great. And then from here, you can change the increment if you want to, or you can just leave it at pi because you're going to be able to click on the points that you need. So if you want to do like pi over 2 is probably a little bit too big. We could do pi over 6 is where it was at. Pi over 8, if you look at that, that lines up really nicely because then my line kind of lines up with my peak and my bottom, my low part here. So it's just up to you. There's no real right or wrong here. Just get a scale that looks good to you. On the y-axis, you want to make sure that you can see, sorry, the highest point and the lowest point. If you can't, you need to adjust these numbers until you do. You have to be able to see the maximum and the minimum. And then the step for y, I just prefer to have 1. It'll default to like 2 or 5 or whatever, depending on how zoomed in you are. I like to be able to see all of the values here. Okay, so I do step 1 here. All right, so grid and axis numbers, I click off of minor grid lines. On the x-axis, you want to make sure that you can see one period, maybe just a little bit more on either side of it, but you want to make sure that you can clearly see one period and you have some sort of pi increment to look at. And then the y-axis, you'll make sure you can see the highest point and the lowest point. And then I just do a step of 1. All right, and you always want to be in radians. That's going to be the default. We want to graph in radians. Okay, so here's our picture, and the first period looks a whole lot like what we drew. We could have continued on in our picture, but the first part is similar. Now, the cool thing about Desmos is that you can click around on here and see all of the values that we had before. So look what happens when I click here. It actually gives me that point. And then remember our period was pi over 2. Wait, it won't stay, will it? It should be showing pi over 2, 3. Huh, usually, I'm not sure why it's doing that. Usually it'll stay right there and say pi over 2, 3. It's saying I'm not quite clicking on that. Oh, it's because it's not, it has to be like an intercept for it to be exact. So we can see this one, we can see this one, and then we can read this one. We know this is at pi over 2 and 3, and you can get close by clicking on it and estimating it. It will show you any maximum, minimum, or intercept exactly. Okay, so this is where I said it didn't really matter if you got your scale exact here, because when you click on it, it'll show you exactly what it is. Okay, so now working backwards, this one we could look at and we could see what the values are. If we wanted to work backwards though, and we wanted to get the period, so let's pretend we don't have the equation here, we just have the graph, and let's see if we can match up and get the same values. All right, so to find the period, you're going to find any one repeated pattern in the graph. So this is a sine graph, and I see that the S goes like this, and then it starts to repeat again. So this is one period. This is one full rotation before it starts to repeat again. Okay, so the purple is my period, or is one period of the graph. So to find the value for the period, I can do the right-hand point minus the left-hand point. So I can do pi over 2 minus 0 is pi over 2. And that's what we found from the equation before. And you might ask, well, what if I don't pick those 2 points? As long as you pick one full picture, it doesn't matter. Okay, so another strategy is to go from like high point to high point or low point to low point. So if I go from maximum to maximum, okay, that gives me one U, kind of like a cosine graph. Doesn't matter that this is a sine graph, it still gives us one picture. Okay, so that gives me one complete picture before it starts to repeat again. And this gives me pi over 8 and 5 pi over 8. So let's see if we get the same value for the period. So we get 5 pi over 8 minus pi over 8 is 4 pi over 8, which is indeed pi over 2. Okay, so any 2 points that you pick on the graph, as long as they form one complete picture, will give you the period. Okay, so we can find the period from the graph. So let's go ahead and erase that. The other thing that we need to find is the maximum, minimum, and amplitude. Okay, so before we found the shift and the amplitude from the equation and we graphed it, but we're pretending we don't have the equation. We've got to get it from this picture. So we know that the vertical shift is going to be halfway between these 2 points, and you can you can see it here. You can eyeball it. It goes 1, 3, 5. Those are evenly spaced. But what if it's messy? What if you can't tell? Well, if you can't just look at it and tell what it is, you're going to have to use the maximum and the minimum. Okay, so the highest point on our graph is 5. The lowest point on our graph is 1. So maximum minus minimum is equal to 4. But that's not our amplitude. Remember that our amplitude goes up from the shift and down from the shift. So this is actually double our amplitude. So if we divide this by 2, that actually gives us our amplitude. Okay, so you do the maximum minus the minimum divided by 2, and that's going to give you your amplitude. Okay, so we can get the period and the amplitude from the graph. Now, looking at this one, if we want to know asymptotes and zeros, we actually don't have them. Zeros would be x-intercepts, and we see that we have none. And asymptotes would be breaks in the graph, and we don't have any. Okay, and you can zoom out and see that it keeps repeating, there's no breaks. Okay, so no zeros, no asymptotes for this one. All right, but we kind of see how one that we know works in Desmos. All right, so let's go ahead and clear this out and let's try another one. Okay, so now we're going to take what we know and what we just learned about Desmos, and we're going to apply it to a new problem that we couldn't have done before. So here's the problem. The distance of a yo-yo from a child's hand is given by y equals sine squared x, where y is in feet and x is in seconds. Okay, so as you know, as time goes by, the distance from the child's hand is going to be given by y. All right. And we want to know, let's say we want to know, we need to have a question to this, don't we? All right, so okay, so graph graph the function and interpret the maximum, minimum, amplitude, and zeros. We want to find and interpret the maximum, minimum, amplitude, and zeros. Okay, so this is our job. Graph the function, find and interpret the maximum, minimum, amplitude, and zeros. All right, so our first job is to graph the function. So I'm going to type this in here. We can type it exactly as it's shown, y equals sine. If you're not sure how to put in the square, remember I showed you the keyboard, or you can type this. It's not going to show it. It's the little top hat symbol. It looks like an arrow up. It's the shift on 6 for most keyboards. And that will give you the square as well. You want to make sure that you do like an arrow over or click off of that to get out of the exponent. Okay, so if you're typing in an exponent, you can use down here. You can just hit that and that's going to put in the exponent, but you want to make sure that you come out of the exponent to type the rest of it. Okay, so what I don't want is I don't want y equals sine 2. See how that's different? I've got the x up in the exponent. That's not good. And it's actually going to give me an error. Okay, so we don't want that one. We want to keep this one. Right? So make sure that when you type it in, the syntax of it, the way that you type it in looks like how it's supposed to look. And Desmos is pretty good. It's better than if you've used like a TI, the typing it in can be quite a challenge, but Desmos is pretty user-friendly. All right, and then the next thing that we want to do is we want to adjust the window. We want to adjust the graph settings. We can see right now we cannot see a period. We cannot see one full period. We can only see one bump of this. So we're going to have to come here. This is still in my settings from before, so I still have grid axis numbers. I need more on the x-axis because I don't see a period. So let's maybe try 10. Okay, so now I definitely see a period. I can actually see a couple of them. That might be good for this problem because we want to interpret what's going on here. So I'm going to go ahead and keep it like this. This step, we can probably go to maybe pi over 2. Doesn't like me doing that. Okay, pi over 2. That looks pretty good. Pi over 2 or pi over 4 might be good. The y-axis looks pretty good. If you want, you can kind of shrink it down a little bit, but I can see okay. So I'm going to go ahead and leave it there. Okay, so these are my settings. Yours might be a little bit different, and that's okay. You just want to make sure that you can see the graph really well and that you can click on the things that you need to click on. Okay, so step one, we graph the function. Excellent. Find and interpret the maximum, minimum, amplitude, and zeros. Okay, so the maximum would be the top of each wave. So that's going to be here. And the minimum is going to be the bottom of each wave. That's going to be here. Okay, everybody see those? All right, so the maximum and the minimum help us find the amplitude. Maximum, minimum help us find the amplitude. So we just need 2 of them. We don't need all of these. All right, so we go from, we're looking at the Y values, 0 to 1. All right, so those numbers are pretty easy to work with, 0 to 1. And that's the maximum, the minimum. So remember to find the amplitude. Oh, hold on, I need my pen back. Okay, so to find the amplitude, it's going to be maximum minus minimum over 2. Okay, so we're going to have 1 minus 0 over 2 is 1/2. Okay, so I'm looking at 1 minus 0 over 2. So the amplitude for this one is going to be 1/2. The maximum is 1. The minimum is 0. Okay, and then the other thing that we want, we're going to come back to interpret. The other thing that we want to find are the zeros. Okay, so let's erase that. So the zeros, remember, are the x-intercepts. Leave this so I can click on it. So the x-intercepts are here and here. Okay, so 0, pi, 2 pi, 3 pi. All right, so let's go ahead and write that down. They're at 0, pi, 2 pi, and so on. And remember, when we have multiples of pi like that, we could write it as n pi in general. Okay, so all of our zeros are at multiples of pi. All right, so we found all the pieces that we wanted. We found the maximum, the minimum, the amplitude, and the zeros. All right, so let's see what these mean. Let's work our way backwards. Let's start with the zeros. Okay, so the zeros are here, here, and here, okay? And we want to interpret this. So let's think about what's happening. This is the distance of a yo-yo from the child's hand. Distance of a yo-yo from a child's hand, where Y is in feet and X is in seconds. Okay, so what's happening here is at time 0, the yo-yo is 0 feet from the child's hand. And then as we go, the yo-yo moves away, and then the yo-yo comes back. So what happens here? This is saying at pi, the distance is 0 again. So at 0, the distance is 0. That makes sense because the yo-yo is in the child's hand. And then they fling it out, and then it comes back again. So at every pi interval, the yo-yo comes back to the child's hand. That's what the zeros mean. The zeros are the time that it takes for the yo-yo to come back each time. Okay, so the zeros in this instant is the time it takes to come back to the child's hand. Okay, so every pi seconds, it's coming back to their hand. Or in other words, every 3.14 seconds. Okay, so let's think about what that means. That is the period. That's the period. From start to stop of one picture is pi. The period is pi. And that's how long it takes to get one rotation. So see, that's what these periods actually, that's what this stuff actually means. So the kid throws the yo-yo, brings it back to his hand. That's one period, one rotation of the yo-yo, and that takes pi seconds, 3.14. Okay, so in this scenario, that's what the zeros mean. Okay, now what they also mean, they have some significance in the distance of the yo-yo. So the minimum is 0. Okay, the minimum is 0. That's the distance from the child's hand. Okay, that means that there's no distance from the hand. That means it's in their hand. Okay, so at 0, it's in their hand. And then the maximum is 1. And we can see that is the farthest distance it goes from the hand. So that would be, in this one, the length of the string. The length of the string is 1 foot. Sorry, my cat is hollering at the door. Okay, so the length of the string on the yo-yo is 1 foot. Now, in this case, does the amplitude have any meaning? The amplitude is halfway between the maximum and minimum. So in this one, the amplitude doesn't really have any meaning because halfway of the yo-yo, I mean, unless I'm not a yo-yo expert, unless there's some tricks or something, the amplitude doesn't really have a meaning this time. Sometimes it does. It doesn't for this one. So in the homework problems, you're going to have to think about this because every scenario is going to be different. See if you can find some meaning for the amplitude in the other problems. Okay, so we found and interpret the maximum, the minimum, the amplitude, and the zeros. And we also talked about how that how the period works into that. Okay, so you guys are going to try some other problems like this, some other word problems, and you're going to try to analyze them and work together. And if you get stuck, you've got some resources and you've got me. And let's see what we can do. Let's see if you guys can do some problem solving with this now that you have the basics.